You do need to go back and watch that intro video if you were distracted, or not that you need to volunteer and say that you were this person, but if you didn't watch the video, you're going to want to go back. There's some foundational things talking about the extreme value theorem, what a closed interval would mean, what it wouldn't mean, things like that. But we're going to start right here. Is this the right spot? I think this is the right spot. Okay, so let's review really quick. This was in the video. Let's see if we can fill in the blanks here. We could say that C is a critical number if f prime of C equals 0, yes. Or if f prime of C is undefined or does not exist. Yep, so these are this is how we find what we call critical numbers. And so these are obviously critical, they're key in finding this. I want to kind of give you a broad perspective of why we want to do this, or why we want to kind of narrow our candidates down. So the guidelines are pretty simple. It says, find the critical numbers of f, we'll work on that. It says evaluate f at each critical number, evaluate f at each endpoint, and then the least of these is the min, the greatest is the max. Right? The last sentence probably makes a lot of sense, right? But let's think this through. Like if I just gave you a random function, like let's get a little bit ahead of ourselves. Let's look at number 1 down there. If I gave you that function, f of x equals 2x minus 3x to the, 2/3? Yeah. What is that next thing where it says on bracket, blah, blah, blah? What is that next thing? It's an interval notation, and it's really giving us the domain, right? It's an x interval. It's saying we only care about this function on the interval from -1 to 3. So what I've essentially done there, I want you to think about this, like thinking back to the story with the little 5th grade girl. When I say on the interval -1 to 3, what I've really done is I have set your world up, right? I've given you a very specific world. Your world starts at -1 and it ends at 3. We don't care about anything outside of that, right? So what if I said this? Speaking about maximums and minimums, what if I said, what is the highest point in Highlands Ranch? And you respond with Mount Everest. I don't know if there's anything called Mount Everest in Highlands Ranch, but if you're talking about the Mount Everest, haven't you left our world? I just defined our world to be Highlands Ranch. I said, what's the highest point? So you can't say Mount Everest or even any of the mountains over there because that's not in Highlands Ranch, right? Wouldn't you have to say something that's in Highlands Ranch? Maybe you'd say like up there by Mountain Vista, some of those houses up there, some pretty high hills, right? Somewhere over there, whatever. But you would be restricted to only Highlands Ranch. What if I said, what is the highest point in the Denver metro area? Now I've redefined your world a little bit, haven't I? Maybe it's Green Mountain over there by Lakewood. That's pretty high, if that's considered Denver metro. What if I took your world and made it even bigger? What if I said, what is the highest mountain in Colorado? You know what the answer is? What? No, it does start with an E though. Elbert. Whoever said that? Yeah, Mount Elbert is the highest mountain in Colorado. It's not a very spectacular looking mountain, it's just very high, right? So depending on what your world is, that's really what we're setting here with the domain. We're saying, hey, your domain goes from -1 to 3. We don't care what happens when x equals -10. We just don't care. We care about what happens between -1 and 3, including those endpoints. But let's take an even broader perspective. Think about it like this. If I just asked you a random question, like let's say you weren't even in a calculus class, and let's say that you didn't have a graphing calculator, and I asked you this question right here. I said, all right, you get this function f of x equals 2x minus 3x to the 2/3 on the interval -1 to 3, and I said, no calculator allowed, maybe other than like a really rudimentary calculator, like not one with graphing capabilities, just a very basic, just only multiplication and exponents and stuff, but no graphing. I said, what is the highest y value for that function on the interval? What would you be left to do? Sorry? Well, you could plug 3 in, but what's so special about 3? Why not 2.8? Yeah, but what if the function is decreasing? Then that would actually end up being the lowest y value. What if the function's doing this? Remember, you're not allowed to have any sense of graphing here, like with a graphing calculator or a computer. If I did ask you this question, if I just said, hey, I want you to find the maximum, the highest point on that interval, Christine suggested plugging in a 3, and I think that's a fine suggestion. I think we would do that. What else would we have to do? Plug in a -1. Okay, I think also that's a good suggestion. What else would we have to do? All of the x values in between, right? Wouldn't we have to plug in the -1 and the 3? Granted, I agree with you. Wouldn't we have to plug in every single other number in between? That would be the only way. And then if we did all that, then we'd be like, that's the highest y value right there. Found it. But could you actually accomplish that task? There's an infinite number of numbers between -1 and 3. So you could say that you found it, but how would you know that that's the highest, right? Because somebody might have gone a little bit further than you and like, no, I found a higher one. So this would be a really terrible approach to this, wouldn't it? So the best approach is to say, all right, we got this function right here. We don't know what the graph looks like. We're trying to find the maximum. Is there any way we could narrow the list of candidates down to only the realistic options? You see what I'm saying? How could we narrow it down to just only the realistic options instead of all these other numbers that, who knows, are they realistic? Maybe they are, maybe they aren't. But how could we get just the realistic options? So here are the realistic options. Here's what we're going to do. Because we are certainly not going to do the thing we were just talking about, right? It's a waste of time. It's never going to work anyways. So what we're going to do is we are always going to try to find our candidates first. Our candidates will involve the things that were mentioned in the little table above. They will involve the critical numbers, and they will involve the endpoints. So your candidates for what we call absolute or global extremes, extrema, like maximums, minimums, the candidates are endpoints, critical numbers. That's it. Okay. And so we're going to be able to find these critical numbers. Did you guys see in the video, I made a little connection in the video between critical numbers and horizontal tangent lines. Did you see that? Yes? Haven't we found a lot of horizontal tangent lines in the last 3 weeks? So critical numbers are where you have a horizontal tangent line. Or perhaps a point of non-differentiability. Okay, so let's see if we can do an example here. That's probably the best way to do this. So take a look at number 1. It says find the absolute extrema. So what that means then is find the absolute max and find the absolute minimum. So our candidates, we want to restrict ourselves to only the realistic candidates. Those are critical numbers and endpoints. The endpoints are obvious. There they are, -1 and 3. Critical numbers. If I'm going to try to find a critical number, in a case like this, what might be a wise first step? Find the derivative. Find f prime. So that's what I'm going to try. Let's see if we can do this together. So I've got f prime of x is equal to, the first one's pretty simple, right? It's just f prime equals 2 minus what?
2x to the -1.
Yeah. 2x to the -1/3. Because, of course, the 2/3 times the 3's would cancel. You subtract 1, you get -1/3. Agreed. Okay, so f prime of x equals 2 minus 2x to the -1/3. The first thing I want to always consider, sometimes we can just check this box mentally. Other times we'll have to do a little bit of work for it. But remember, critical numbers are where f prime is 0 or does not exist. So I want you to think real hard about this. This f prime right there, are there any x values that would cause f prime to not exist? Any x values, like, I mean, and I'm trying to get you to think, like, if I plugged in a whatever for x, any of those whatevers, any of those numbers, could they cause f prime to not exist?
Would it be any positive ones? Because, or any negative ones?
You can do the third root of a negative.
Oh, you can?
Yep.
Oh, right.
You can do a third root of a negative. Jonathan?
Because when you do like the negative exponent, you get 2 over cube root of x. So if you do 0, then the denominator would just be 0. So can it not be 0?
You guys listening? It's exactly right. It's exactly right. What we don't see here, and he saw it, isn't x to the -1/3 really a denominator? So this would really be f prime equals 2 minus 2 over, and he said cube root of x. If you just wanted to leave it as x to 1/3, of course, that's fine too. But yeah, that's what it is. And so if you plugged in a 0 for x, wouldn't it cause the second fraction to be undefined? Therefore, the derivative would not exist. Does that make sense? So that will not always be the case. We won't always see critical numbers like this, but you always want to at least mentally check that box and be like, okay, f prime will always exist, or in this case, hey, there is actually one number where f prime won't exist. So my candidate, oh, sorry, go ahead.
So
Why can't f prime be, well, so if we plug in a 0 for x, then of course we get 2 over 0, right? And we cannot divide by 0. That doesn't mean that that term goes away. It's not like 2 times, or it's not like it's 2 minus D, and E, so the answer is just 2. Like if any part of an expression doesn't exist, then the whole thing doesn't exist either. So yeah, we'd have to say, hey, can't plug in a 0 because if you do, it'd make the whole thing not exist. Okay, so our candidates. Of my list of candidates, I'll just put them up here. My candidates will involve the endpoints, -1 and 3, and we just found out that one of the critical numbers is 0. That make sense? Now, critical numbers don't only come from where f prime doesn't exist. They also come from where f prime equals 0, right? This will be the more common thing that we see. Far more common to set f prime equal to 0 and get some critical numbers from that. So I'm going to do the same thing. So I'm just going to write 0 equals 2 minus 2 over the cubed root of x. And now we're going to try to solve this. So this is where your old algebra, skills, solving equations comes into play. What would you do first? Subtract what?
2.
Okay, so it'd be, -2 equals -2 over the cubed root of x. What would you do next? Yeah, why wouldn't you just multiply both sides by cube root of x, right? We want it out of the denominator, right? We don't want it down in there. So why not write -2 times cubed root of x equals -2. Now what? Yep, so when you divide by -2, you get 1 is equal to the cubed root of x. And so yeah, you cube both sides and you get x equals 1. Okay, so that is our final candidate. Remember, we don't want to try to plug in an infinite number of inputs to try to figure out what the highest output is, or the lowest output, for that matter. Whoops. And so we found our candidates. -1, 3, 0, and then the final one is a 1. Is this making sense from just a broader perspective? Like we're trying to find the candidates, find the numbers that might actually be it, instead of just plugging in a bunch of random stuff. Macy?
Will there always be 4?
Nope. Sometimes there'll be fewer than that. Sometimes I would say it'd be rare that we'd have like 5 candidates or 6. Just from a time perspective, it doesn't make sense. But yeah, I'd say 3 or 4 is very reasonable for sure. Sometimes it'll only be the endpoints. Yeah.
Well, if this was, instead of cube root, if it was just the square root,
Yep.
wouldn't it be plus and minus 1?
Yep.
So then we'd have 5 there, right?
Well, except -1 matches one of the endpoints, so we wouldn't have to do it again. But if the domain were changed, then perhaps, yeah. Yep. Yeah, so you could have all kinds. Feasibly, you could have 30,000
Yeah.
candidates. Obviously, we're not going to do that because there's only so much time, but you could have an unlimited number of them, really. Okay, any other good questions there? Those are awesome. We will bring this back around to a graph in just a couple minutes, but I want to do this just totally without a calculator, with a little bit of an exception, without a graphing calculator for this point right here. So here's what we normally do. If I asked you, think about this, if I did ask you, find the highest point or find the lowest point, if you just started plugging numbers in, you'd be plugging x's in, and what would you be getting out? Y values, right? And we're going to be comparing the y values. So what we do to typically, compare would just be to make a table. We're talking old school Algebra 1, make a table, input, output, right? So your x is your input, your y is your output, and then we just put all of our candidates in there as x's. So I would go -1, I'll put them in order, 0, 1, and 3. And then all we do is we take those and we plug those back into f of x, and we decide which one has the highest output, which one has the lowest output. So some of these I think we can do pretty quickly. For instance, what if you plug in a 0? What's the output?
0.
Yeah, you just get 0 minus 0, so we can do that without a calculator. You can actually do the -1 without a calculator too. What is -1 to the 2/3? It's just 1, right? So it ends up being 3 times 1, but then you plug in the -1 in there with the x by the 2, you get -2. I'm coming up with -2 minus 3. Does that make sense? You can do all this in a calculator if you want. I think it's just fun to try it without. That's -5. Does the 1 work?
Yeah.
You could do that without a calculator too. What does that end up being? No, I think it's -1. I think the 3 is where you'd need a little bit of calculating power to get a decimal. So try that out. We're just plugging back into f of x, right? We're just trying to say, what's the highest y value? What's the lowest y value? That's all we're really doing here. And then we'll tie this together, hopefully with a graph. once you guys have that, let me know what's the output for x equals 3.
Should it be decimal?
It definitely should be a decimal, yeah. 3 to the 2/3 would be a decimal. What, did you get it?
Yeah, I got negative 0.240.
Negative 0.240. Do you guys agree with Mandy's number there? No? Yes? Okay. Sorry, Pristine. I'm sure it'll eventually stop. Yeah, it is distracting. Okay. So the final thing we need to do here is we need to identify the max and the min, right? And so we're going to use the y values to do that. So we're just going to use this side here. So I would come over to the side and just say the max is, and I'll just list the x and the y coordinates. So the max, what would it be? The max, I think, would be 0, 0. Because you basically have 3 negative outputs. Right? Negative 5, 0, negative 1.
Oh, I thought that's a 0.5.
Oh, no, sorry. Yeah, that's a negative. There we go. So yeah, the max would be 0, 0. And then the min would be what?
Negative 1, negative 5.
Yep, negative 1, negative 5. So the way that you're really justifying yourself is your work. The work that you found your candidates, and then the table in which you used to compare. That's your work. That's what you would use to actually prove that you're right, as opposed to you just randomly guessed. What do you guys think? Will you turn to your calculators really quick? Take your calculators, and maybe you've done this already. Will you guys graph f of x on your calculators? And, sorry? So, say again? Can you see the sharp point? Where's the sharp point at? 0, 0. Yes, there's a good connection to be made there. Please, though, when you graph it, go ahead and put it in your y equals. But then, before you hit graph, hit window and set your domain to negative 1 to 3. Okay? That way you'll see the exact picture of what we are looking at here. Domain of negative 1 to 3. I'll do the same thing up here. So it would be 2x minus, was it 3x to the 2/3?
Yeah.
To the 2/3. And so what I'm talking about with the window, instead of graphing it, I'm going to push window. And I'm just going to say window. Let's go from an x min of negative 1 to an x max of 3. And then for my y min max, I'll just go like, negative 6 to 6. Something like that. And now I hit graph. That makes sense? We're just going to try to get a picture of what we actually were working with. So this is negative 1 to 3. There is the point of non-differentiability, right? That's 0, 0. And then you can see as it continues on over to the right, it never actually quite makes it back up to the x-axis, right? So what I would encourage you guys to think about, I don't know if I can draw on this. Can I draw on this? Beautiful, I can. So this right here was your 0, 0. So that was our max. Can you see graphically how that's the max? And then what was the min again?
Negative 1, negative 5.
And that's right here, isn't it? So you can see that's negative 1, negative 5. That's the lowest possible. What was this right here? That's a critical number. It's a turning point. Wasn't this when x equaled, was it 1?
Yeah.
That was one of our candidates. So this is a horizontal tangent line. So isn't that a relatively low point? Like that's where there's a little dip, right? A little valley there. But that's not the lowest, right? And then over here was the other endpoint. And you can see the other endpoint didn't quite make it above the x-axis. Obviously it falls below 0, 0. And that's why 0, 0 was the max. And this left endpoint was the min. Tying it together with a graph, does that help? If you had a graphing calculator and I asked you this question, wouldn't you just graph it and be like, there's the min, there's the max? Right? It'd be super, super straightforward. So in situations like this, I'm going to want to see why you picked what you picked. One word about this. In pre-calc, did you guys ever use the max-min finder?
Yep.
You're welcome to use that in this class, but if that's your justification, you get nothing. That makes sense? So, in other words, it could very easily write that capability out of a question. And so the fact that you're good at the max-min finder in a calculus class, not really going to help you, okay? So please don't say, I hear what you're saying, Mr. Anderson, about the candidates and it sounds all cool and everything, but I'm just going to use my max min finder. Just, if you do that, just put an x and minus 5 or whatever. You're not going to get any credit for that question. Totally serious about that. Okay? Yeah, go ahead.
Okay, so say you found 0, 0, like in the calculator, how would you justify that so that you got points? Like,
Did you do all the other stuff? Did you find your candidates and...
sure. Is that enough? Like, is the work that we just did?
Yeah, the work that we just did, all the stuff you saw in this...
Write a statement or anything?
Well, the only statement we wrote was the max is this, the min was that. That's all you got to do.
Okay.
for-
You
for-
can, like, check your work with your calculator.
Well, probably not. Like if I asked you a question like the one we just did, so if I asked you a question like the one we just did, I would say, I would not give you the calculator for it, other than the fact that I would have to rewrite it a little bit because the 3, not going to be able to do that without a calculator. But if I made the right endpoint 8, you could definitely do that without a calculator. So if I rewrote it to be, instead of from -1 to 3, I made it -1 to 8, I would 100% give that to you with no calculator and expect you to be able to do it. Because you can do the third root of 8. Does that make sense? So yeah, there's not going to be like a, in other words, you got to really actually be able to do what we just did. You're not going to get the opportunity to be like, and now I'll turn to the calculator, because you won't have the calculator for that part. Yeah. Good question. Anybody else? Okay, so we're going to pick up the pace just a little bit now that you kind of have a sense of what's going on. Okay. So number 2 says, find the absolute extrema of h of x equals, and it gives you that whole thing right there. And then our world, our domain is -4 to 4. So I'm going to ask you this question a whole bunch of times for the next couple weeks. Actually, longer than that. We take a long time with chapter 3. My question is this. What are your candidates for absolute extrema? I mean, how many numbers are there between -4 and 4? Infinitely many. Do you want to try to plug all those in? No, nobody wants to do that. So what are the candidates? What are the realistic options? Where do we get those from? Endpoints? The critical numbers. Yeah, endpoints and the critical numbers. Sorry, John, they kind of just overpowered you there. You were a little bit slow on the uptake. Okay, so endpoints and critical numbers. So, all right, how much work do you have to do to get the endpoints? None. They're right there, -4 and 4. Critical numbers, though, yeah, we do. So critical numbers are places where, what happens? Derivative, in this case h prime, is 0 or undefined. So if we're going to make a judgment on any of that stuff, we probably should find h prime first. I think you guys can do this. I'll just work quietly up here, and we can compare answers in a second. Just trying to find h prime. Well, let's not get too far ahead of ourselves. We're already talking about like factoring and solving and all those things. What I want you guys to think about first, you have to at least think about this. Critical numbers come from places where h prime is 0 or doesn't exist. Is there anything you could plug in for x that would cause this to not exist? No, because with number 1, we found that 0 would cause that exact thing to happen, right? Are we going to see something like that happen here? No, there's no denominators, right? There's no denominators anywhere. And so the idea of h prime being not existent, I don't think we have to worry about that one here, right? We did with number 1, but not with number 2, just because of the nature of the function. But we want to set this equal to 0, and here is where I want to make a point. I didn't make this point earlier. From a grading perspective, like I'm picturing you guys taking your quiz later on, your test later on, or even the AP test, you guys realize how many points this is worth. That's worth a point. And you start saying, oh, golly, it's just a point. No, you don't want to say just a point. It's worth a point. It's worth holding on to. The fact that you set h prime equal to 0 tells me you know what you're doing. It tells me that you are trying to find a critical number. Now, might we make mistakes, moving on? Of course. But that at least tells me I know what a critical number is. I know what I'm looking for. Okay? So you want to always write that down. You never want to just skip over that. The equal 0 is almost always going to be like a really important thing to write. So, your suggestion, Pristine, how could we solve this thing? Do some factoring. I think even before we factored it, because it's an equation equal to 0, we can simplify it by doing what? I think I would just divide everything by -3, right? So we literally are taking it out. So I would just go divided by -3 on every single term. I'm allowed to do that because I'm going to divide the 0 by 3, and that's actually nice and handy. So it ends up being x squared minus 2x minus 3 equals 0. And now Pristine's idea just got even easier, didn't it? All right, so which numbers work here? X and x plus this minus that, what do we get?
X plus 1, x minus 3.
Plus 1 and minus 3, I agreed. So x plus 1, x minus 3 equals 0. So what does that mean our critical numbers really are? Negative 1, yeah, take them to the other side, so it's negative 1 and 3. You see all these old algebra skills that you learned? Do you see how these are just mere footnotes on the way towards something bigger? You got to be good at this stuff. You got to be good at factoring like we practice with limits, so definitely good stuff. So guys, we've got all of our candidates. Here they are. I'll make a little table. Our candidates are negative 4, negative 1, 3, and 4. The numbers get a little big here. Definitely doable without a calculator. If you want a little bit of help, maybe with some of the bigger numbers, I'm fine with that. But let's see if we can complete the table and come up with the absolute max and the absolute min. Question?
So there's no more of them just because there's nowhere that this is undefined?
Yeah.
Oh.
So these, yeah. So when we talk about that, like unenviable task of plugging in all the numbers between negative 4 and 4, we have, based on our work, we set h prime equal to 0. We considered the DNE. Because we considered that and we found where h prime equals 0, there are no other numbers that make any sense for absolute extrema. These are the only candidates that we would ever consider.
Okay.
Yep. Who's number 4 up there?
That's not even the one we're in.
Yeah, wait, mine just.
Oh, it's number 2. It's number 2.
Oh. That's one.
Number 2.
I thought I saw a reflection of like a... Caroline.
Because it was on Friday.
There we go. All right, so like I said, these numbers are a smidge big, perhaps doable without a calculator. Obviously, a calculator makes it a lot easier. So what did you guys come up with for the y value when x is negative 4? 68. Okay, we're going to go with your numbers here. So 68 for that one. How about the negative 1? What does it end up being? 4 minus 5. Negative 13. Yep, agreed. Negative 13 there. We're just plugging back into h of x to get the output for whatever input we've got. So when you plug in a 3, I'm getting 19. 19, okay. And then you plug in a 4. Let's see here. Let me just make it interesting. So it'd be negative 64 plus 48 is negative 16 plus 36 is 20. 12. 12? 12, okay. So there we go. Sort of big numbers like that. 68 obviously is pretty large. But it's in the realm of reasonable numbers, right? It's not like 10 billion, 392 million, blah, 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 right? So we've done a lot of work here, but we haven't really answered the question yet. We've just drawn a table. Dan, what's the answer? The absolute max is?
Negative 4, 68.
The max is negative 468. And the min, Dan, is? Negative 1, negative 13. You always want to call those out and say, I got my table, I got my work. That's all good and everything, but here's the answer. I identified the max and the min. Yeah?
So for the A/B test, do we have to say like the max in the interval negative 4 to 4 is this answer?
That's a great question. I mean, I think if we wanted to be like real formal about it, that's totally true. That's exactly what we would want to do. But I think the fact that we're talking about a function that's defined on that interval, and all of your candidates were within that interval, I don't think you have to say that.
Okay.
But certainly no one's going to be like, oh, yeah, he's out of the point now. That's definitely correct. But I don't think we'd need to say that. Good question, though, for sure. Anybody else? Okay, good deal. Let's move on. Let's try number 3. You guys are seem to be getting a little momentum going here. Go ahead and look at number 3. It's our old friend trigonometry. See what we can do. So you guys jumped into this right away. You went to go find f prime. Maya, what did you find for?
Sorry. I'm so tired. What?
What'd you find for f prime?
I got sine of 2x times 2.
Sine of 2x times 2. Did you guys get the same thing?
Yeah.
Well, we'll get there in a second. Delaney has asked me a couple times, she's like, would we set that equal to 0? Would we set that equal to 0?
Yes.
We would, but can we at least consider the DNE first?
Yeah.
Is there any number we could plug in for x that would cause f prime to not exist?
No.
Sine. Think about the graph of sine. What does it do? Doesn't it just do this forever?
Oh, yeah.
Are there any places where, are there any like discontinuities like holes or jumps or? No, it's just continuous everywhere. Yeah, so I would say that there's nothing we could plug in for x that will make f prime not exist. So then I think we jump right to what Delaney said, and we set it equal to 0. So f prime equals 0. Guarantee you right there, if this were a quiz question and you wrote that right there, I'm thinking you definitely have 2 points right now. Because you found the derivative correctly and you just set it equal to 0. Make sense? Yeah? Okay. What do we do now?
Divide by 2.
Divide by 2. Okay, I like that. So we end up with sine of 2x is equal to 0. What do we do now?
Take the... Do pi.
Aren't we trying to get the x by itself? How do you undo sine?
Sine inverse.
Inverse of sine. Yeah, so I would go inverse of sine to both sides. So inverse of sine here and here. So these cancel out. I just end up with 2x equals inverse sine of 0. Now what do I do?
Divide by 2.
Before we divide by 2, guys,
Solve for the...
we got to do the right side. How do we do the right side? Yeah, you could do some triangle stuff with SOHCAHTOA, or you could do the unit circle. Basically, the right side is asking you this question. What angle or angles has a sine of 0? In radians. So 0 and pi, 180 degrees, yes, but in radians. So 0 and pi, aren't there others if you just keep going around? 0, pi, 2 pi, 3 pi, 4 pi, every pi essentially, right? So here's what I'm going to do. Not apple pie, unfortunately. As much as we might want it to be that, it's not. So if I did 0 pi, 2 pi, 3 pi, I just could put eventually ... I know there's tricky little fancy ways to write, plus pi n or whatever. I get that. But we're just trying to find a limited number of numbers here. Wouldn't I now divide by 2?
Yeah.
I'm going to divide everything through by 2. So divide by 2, divide all this stuff by 2. I end up with x equals 0, pi over 2, pi, 3 pi over 2, ... So on and so forth. But now we got to remember, our little world is pretty restricted, isn't it? Our domain is quite tight, and there's not going to be a lot of these numbers that fit in there. Does anybody know which number or numbers actually fit into our domain? 2 of them?
No, I was saying number 2.
Oh, number 2, so pi over 2? Yeah, because pi over 2 is like 1/2 pi, so that would be slightly less than 3/4 pi, but slightly bigger than 1/8 pi, right? Isn't 1/2 in between 1/8 and 3/4? Yeah? But then once you get to 0, that's too low. Pi and 3 pi over 2 are too high. So from a critical number perspective, we would ignore this one, we would ignore this one, we would ignore that one, and we'd only use pi over 2, because that's the only one that actually fits in our domain. Does that make sense? Okay, Caroline, you had your hand up a second ago.
So before you divide by 2,
Mm-hmm.
can you eliminate the ones that are outside of your domain?
No, you have to divide by 2 and then make that judgment. Yep. Yep, good question. Because if you try to decide before you divide by 2, none of them fit. Right? None of them. You have to get the x by itself first before you make that judgment. Okay, yeah, 0 and pi don't fit, so yeah, we'd just be out of it. All right, so we're not out of the woods yet with unit circle stuff. Here are the candidates for absolute max and min. Pi over 8 is our lowest one. Pi over 2 is the next one up. And then finally, 3 pi over 4 is the biggest one. And you can definitely do all of these without the calculator. So those of you that are like, cool, I'll just do the calculator here in class, I would encourage you to stop and think, talk to classmates, talk to me, try and continue to develop and get better at the unit circle stuff. Let's evaluate. There's 3 of them. Give it a go. If you know your unit circle, you're probably almost done right now. If you don't, we got a problem. I would, here we go. I would say, maybe you guys did this as well. So I would say for the first one, y equals negative cosine of 2 times pi over 8. What is 2 times pi over 8 really if you simplify it? And cosine of pi over 4 is root 2 over 2. Of course, there's the negative out front, so we'd end up with negative root 2 over 2. For those of us living in, being able to do trig, this is how quick it could be. I love for all of us to be in this place where we can do this quickly. For the second one, we'd write y equals negative cosine of 2 times pi over 2. And of course, once again, the 2 would cancel with the other 2. So there's cosine of pi, which is negative 1. But then the negative out front turns it into positive 1. All right, so there's my output there. And then y equals negative cosine of 2 times 3 pi over 4. Of course, the 2 and the 4 once again cancel to be a 2. So it's really cosine of 3 pi over 2, which is, and the negative, of course, at that point doesn't really mean anything, so you just get 0. Now, we might not know what root 2 over 2 is directly as far as decimals, but can't we still make a judgment on max and min? I would say the max is what? Yeah, because 1 is the only positive output. Yeah, so pi over 2 comma 1. And the min is what? Yeah, the only one with the negative output, right? So it'd be pi over 8, negative root 2 over 2 would be my min. We're finding maxes and mins. Remember, that's what chapter 3 is all about. With one little exception, we do something else, but it's all about finding maxes and mins. Are you getting that theme? Okay, we got one more. Number 4. Let's take a look at it. Let's restrict ourselves to 0 to 12 for our interval, our domain. They do cross, don't they? Yeah.
They cross at
2? No.
edge equals
8.
Yeah.
Because 8 to the 1/3 and 1/4 of 8, same thing. Yep, that makes sense. I was saying the y value, wasn't I? Yep. Okay. So did you guys get a similar graph to what I've drawn up there?
Yes.
Might be a little stretched differently or whatever, but same basic idea.
I had to check.
And 12 would be out here roughly, so on and so forth. So this is now talking about two different functions, and it says, what is the maximum distance between g of x and f of x? Because it talks about distance, I'm thinking we might want to have something to actually represent distance. What letter would you want to use to represent distance? D for distance, makes sense. Okay, and then what would distance actually equal in this case? Yeah, to find distance between two things, don't you subtract one from the other? Yeah, so I think g of x minus f of x makes a lot of sense. So g of x minus f of x. Okay, so I'll be a little more specific now and actually write what these things are. So d is equal to x to the 1/3 minus 1/4 x. Okay, so we're trying to find the maximum. We're not really worried about minimums on this one, just the maximum distance. What would you say the minimum distance between these is? 0, right? Because they actually intersect in 2 points. So the minimum is 0, so we really don't care about that. We're looking for the maximum distance. Yes, sir?
Wouldn't every point after they cross then be negative distance?
Distance can only be positive. Displacement can be negative, but distance has to be positive. Good question. And of course, negatives, the more negative you get, the less they'd be, right? So, yeah. All right. Question? Yeah.
So the minimum is 0, but why wouldn't, because they're the same distance when they intersect at the other points,
Yep.
why would they both be the minimum?
They would both be the minimum. Yep, there'd be two instances where distance was 0. Yep. Yes, sir.
So would you just find the y distance, or would you have to find the x and y component?
Just the y. We're just speaking about vertical distance in between them. Yeah. So we're saying like for any given x, what is the maximum distance? Good question. Okay, so our candidates for maximums on an interval, where do we get our candidates from? Critical numbers and endpoints. I know maybe it might be out of fashion to say it for the 4th time, but I will keep asking it a 5th, 6th, 7th, 20th, 30th time until we're all solid. All right, so here we go. Endpoints and critical numbers. The endpoints are obvious. They are 0 and 12. Critical numbers, less obvious, right? Okay, so how do I find critical numbers? Well, no, let's not worry about both. What am I trying to minimize? Derivative of what? Distance. And so it's not about setting g prime or f prime equal to 0. It's about setting d prime equal to 0 because I'm trying to minimize my distance. I'm not trying to minimize g or f. I'm trying to minimize distance. So we want to find d prime. What does d prime equal? Any takers? 1/3 x to the negative 2/3 minus 1/4. Like we did before, we have to look at this, and we all know d prime equaling 0 is something to consider. Are there any numbers that we could plug in that would cause d prime to not exist? 0. Isn't x to the negative 2/3 a denominator? Yeah, so you want to be really careful and consider that. That doesn't come up a lot, but it does come up every now and then. So I'd say 0 is a candidate. So if I make my little table over here, my first candidate is going to be 0. Doesn't it happen to match up with one of the endpoints? So it's not like if you forgot that one, you'd be out, right? Because it matched up with an endpoint, but it's okay. You still want to think about it. We also want to consider, of course, where d prime equals 0. Now we've got an equation to solve. What do you guys think? How could we solve this? What would be a good way to do it? Suggestions on a first step. Plus 1/4, that works. So it'd be 1/3 x to the negative 2/3 equals 1/4. What else? Okay, so if you divide by 1/3, it's the same thing as multiplying by 3. So x to the negative 2/3 equals 3/4. Now what? How do we deal with this negative 2/3 exponent? Okay. You can write it as 1 over. Yep, I think that makes sense. 1 over x to the 2/3 equals 3/4. Now what? Multiply it over. Okay, good. So you'd end up with 1 equals 3/4 times x to the 2/3. Now what? Divide by 3/4, which is the exact same thing as multiplying by 4/3. I'll keep going here. We're definitely taking the long way around, but that's okay. 4/3 equals x to the 2/3. Sorry? Okay. So what do we do now?
Take the cube.
You
Or
just
the-
cry inside.
The cube
Guess and check.
root square.
Guess and check.
Me.
Okay, let me put it to you like this. You have calculators perhaps available for this. We'll see what we can do with this. But don't I want it to be x to the first? Like I'm solving for x to the first, not x to the whatever. So how do I get a 2/3 to be a 1?
Plus 1/3.
Plus x to the 1/3.
You multiply it by 3 halves. So what I'm going to do is I'm going to take the right side to the 3 halves power. I'm going to take the left side to the 3 halves power.
Oh my gosh.
You have a calculator. You can use it on this one. It's okay. We already used it. We'll use it again. So, of course, these cancel out to be x to the first. And what is 4/3 to the 3 halves power?
And number.
Uh-huh.
Oh dear Lord. 1.51.
You guys agree with that? 1.51. Let's get a few more decimals than just that. So 1.5, is it 139?
1.5396.
1.5139.
5396.
Oh, 5396. Okay. 5396. So that's our second candidate. And our final candidate is 12. Okay. you got a calculator on this one, so it's not that bad. If you plug in a 0, what do you get? 0. You're going to have to do a little bit of work with the calculator to, to plug in those. We'll be able to identify our max from that. So the max is, I'll let you guys figure it out.
Well,
What'd you get?
0.76.
Okay, output for either one of those two. What'd you guys get? 1.5396. What'd you get?
0.76.
0.76 what? Okay, and then how about when you plugged in a 12?
-0.7105 or 106.
7105?
7106.
7106. Okay, well, I'll leave it at 5 right there. So the fact that that's negative, I'm not too concerned about it, because remember we're talking about distance, right? So what is the absolute value of that? It's of course positive 0.71. Isn't the distance at 1.5396 still bigger? So I'd say the max distance is 0.7698. Okay?